So in this video, I'll go through and analyze a heating curve to explain the different components of the curve. So a heating curve simply allows us to get an illustration of what happens as heat is added to a substance and how it affects the temperature. And so in some cases, you're going to add heat and it will cause an increase in the temperature, but you also get to areas where even though heat is being added, there is no change to the temperature initially. And so these points occur at the phase transition. And so when we look at a heating curve on your y-axis, so the vertical axis, you have your temperature. And so, of course, it's going to start from a lower temperature to a higher temperature. The values of the y-axis will vary because some substances will be in the solid phase at a certain temperature, whereas others may be in the liquid phase at that temperature. But you still have the same general guideline. You go from the lower to the higher temperature on that y-axis, and your x-axis, the horizontal line, it's showing what happens as heat is added. So as more heat adds to the system or to that object, what is happening to the temperature? And so when you think about the different phases, of course, with the physical states, we have our liquids, we have our solids, and we have our gases. So the best way to think about the heating curve and where the temperature should be, think about water. That is one of the more common examples, something that everyone can relate to. You have water in the different physical states, water as a solid, which we refer to as ice. You have water in the liquid phase, and then you have water in the gas phase, which is water vapor or steam. So just think about those three states of water and what happens to the temperature. The lower the temperature, you're going to start to see more ice. As the temperature increases, the ice melts to become liquid water. As the temperature continues to increase, the ice begins to vaporize or boil and converts to the gas phase. Think about that, and that will help you with your heating curve. So at the lower temperature, you're going to have your solids. And so this section represents the solid. So depending on what temperature you're dealing with, it can go up till you get to the point in which your solid starts to become converted to liquid. And so with water, it is solid anytime it is less than 0 degrees Celsius. So anything below that is going to be the solid phase. But as heat is added, once it gets to 100 degrees Celsius, it then starts to enter the phase transition. So when you see this horizontal line, heat is added, but no temperature change takes place. This represents what we call the phase transition. So at this point, melting takes place. Or if we're going down in temperature, we will be freezing. So depending on which way you're going, it's either melting or it is freezing. But for this example, I'm going to increase my temperature. So I'm showing what happens as we go from a lower to a higher temperature. So going from a lower to a higher temperature, we're beginning to melt the solid. And at that stage, we're in equilibrium where you have some water. Since I use that as my example, some will be present in the solid phase, some will be present in the liquid phase. So you're going to have a mixture of those two physical states there. But as the heat is added, no temperature change is initially observed. However, once all of the solid has now been converted to liquid, so in other words, once all of the solid has melted, then you start to see an increase. So then we get to the liquid phase. The liquid phase will continue. So as heat is added, it will remain in the liquid phase until we reach, for water, 100 degrees Celsius. So these two temperatures that I've provided, the 0 degrees represents the melting point or freezing point of water. The 100 degrees Celsius represents the boiling point of water. And so as long as the temperature for water is between 0 and 100, it will remain in the liquid phase. However, just as we saw with the solid, we reach the point after we get to 100 degrees, the liquid starts to vaporize. So some of that liquid is now being converted to the gas phase. So at that point, you have a mixture of the substance in the liquid phase and the gas phase. And this is where the boiling or vaporization takes place. So at the boiling point, you have a mixture of liquid and gas. And as heat is added, more and more liquid is being converted to gas until you reach the point where all of the liquid has been converted to gas. Once you reach that point, you are now in the gas phase. So anything above the 100 degrees, you are now in the gas phase. And so we can look at the temperature of a substance or where on this heating curve we're dealing with, and we can determine and identify what physical state of that substance is present. So regardless of what the substance is, the heating curve always shows us our solid, I'm going to just put an S, our liquid, and our gas, and then the areas in between that, these horizontal lines, indicate the phase transition in which we're going from one physical state to the other. So melting or freezing, as well as vaporization or condensation, depending on whether we're going up or down. But that is how we look at a heating curve to determine what physical state we're dealing with. It simply depends on what temperature we're at, and that will allow us to determine where we're at in terms of the physical state. Again, I used the values for water. If we were looking at any other substance, we would simply think about what that melting point is and what that boiling point is, and those are the temperatures that you will see on that y-axis. Anything less than the melting point, you're in the solid phase. Anything between the melting and the boiling point, you're in the liquid phase. Anything above the boiling point, you're in the gas phase. And so that's how you interpret a heating curve. So I hope this helps.